Hi, this is Mrs. Kasperwitz, and in this video, I'm going to talk to you a little bit about the science practices and how we go about studying the natural world around us as scientists. So let me click on present here and we'll get started. So we are on page 8 in your yellow Unit 1 note packet, and we're going to talk about the science practices. Now, you probably are familiar with the vast majority of these practices from studying the scientific method in the past. So when we talk about the scientific method, or when you learned about the scientific method in the past, it was kind of presented to us as a set of steps that we go through, right, to study natural phenomenon in the environment. And it's not wrong, it's just not as accurate as we'd like it to be, right? So we don't have to follow those steps in that exact order each and every time we're looking at some problem that we're trying to solve or some phenomenon we're trying to explain. So we're just kind of switching our perspective a little bit and saying these are the things that scientists do. These are the practices that scientists do when they're studying a natural phenomenon. And the order in which they're done doesn't particularly matter, okay? What matters in the end is that somebody can repeat my experiment and get the same result. And if that happens multiple times, then my explanation for that phenomenon is something that we can add to our scientific knowledge, right? So the science practices are how people do science. It doesn't matter what phenomenon they're studying, and it doesn't really matter in what order you do them. So let's take a look at the first one. And this is similar to one you already know, right? So science practice number 1 is to ask a question or define the problem that you are trying to solve, all right? This is the same, one of the steps that's in the original scientific method, but we're just going to call it a science practice. And so one of the things that scientists do is they ask lots of questions, right? And we're going to be talking about how to do that, and there's different kinds of questions that you can ask about phenomenon or about things that are happening in your environment. So later on this year, we'll be taking a look at some of those kinds of questions and how we might answer them. Science practice number 2, developing and using models. So this one isn't specifically in the steps of the scientific method, but this is something that scientists do to help them make predictions about the natural phenomena that they're studying. So a science model or a model is going to possibly help us make some predictions or hypotheses about the natural phenomenon that we're looking at based on what we already know, right? And then as we do our experiments and things, we can add to our model, right? And eventually that model might become an explanation for the natural phenomenon that we're studying. So we do a lot of modeling. So here are some pictures, right? This would be kind of a classroom model, right? And this would be modelings of hurricanes, right? So if you watch the weather pretty much any night, all right, they use models to predict weather patterns all the time if you're a meteorologist. So that would be an example. And we have models of cells, and we have models of enzyme reactions that we're going to be talking about this year. Models are a way for us to visualize a natural phenomenon that sometimes is hard to see in reality. Science practice number 3. So we're going to plan and carry out investigations. This is the designing an experiment part of the scientific method, right? So we are going to learn how to plan and carry out a good scientific experiment and what the pieces and parts of that are. And knowing that and being able to design an experiment that's going to lead to useful and valid results is important to scientists. Again, because of this idea, we need to be able to repeat those investigations and those experiments so that we can verify the results that we're getting. Science practice number 4. We just finished a lab with this in class, or excuse me, in lab, and we are now moving on to bar graphing and line graphing in lab where we're doing this. This is a science practice. We're analyzing and interpreting data. So the data that we've collected in an experiment, or we're looking at data that other researchers have collected, and we're learning how to analyze and interpret that using graphs and other visual representations of that data. Science practice 5, using mathematics and computational thinking. So in our analyzing and interpreting data lab, we talked about taking an average. That's using mathematics, right, to understand or get some knowledge about the data that we've collected. So one of the science practices, and this is where science and math and technology kind of all merge together, right, STEM, is we need to use some math in order to help us understand what our data is trying to tell us. Science practice number 6 is to construct an explanation. So we've actually already practiced this as well when we did that activity with claim evidence reasoning, right? So that is a method, claim evidence reasoning is a method for constructing scientific explanations, right? So we're going to make some observations, we're going to make a claim about what we're observing, and based on the evidence of our observations, we're going to try to come up with an explanation for what we're observing in nature. And scientists do this all the time. They're trying to construct explanations for natural phenomenon in the environment. Science practice 7 is engaging in argument from the evidence, right? So once we've collected that evidence, we need to be able to communicate to other people our data and our findings and our conclusions. And those things have to be based in evidence. So this is, again, our claim evidence reasoning piece, right? Where we're going to defend our answers, we're going to defend our findings or our conclusions based on the data, based on the evidence that we have at hand, and on our background knowledge of science. So this is where the factual part comes in. We need, when we're doing our reasoning, we need to pull on our background knowledge of science, the fact stuff that we already know or have observed. And lastly, we have science practice 8, which is obtaining, evaluating, and communicating information, right? So this is where being able to write, right, and effectively communicate our results to other people and to the community is important, right? So we need to be able to communicate our information to others, and we also need to be able to evaluate that information that we get in the media and reading the newspaper and all that kind of stuff. So that's the evaluation part. Not only should you be able to communicate what we've learned scientifically, but we also need to be able to evaluate the science that's being presented to us, the data that's being presented to us, and determine whether or not that information was collected in an appropriate way, was there bias introduced by the experiment, who's communicating this information, and do they have an agenda? So that's a science practice that we all definitely need to be aware of and practicing as good consumers of information in our communities. So instead of looking at the scientific method as a set of linear steps where we're just going to draw a straight line and this is how we always go about how we do science, in reality, science is more like these intertwined circles. Scientists are always kind of working around those science practices, right? And it's not always a linear step. We might have to verge off a path and come back and do some more research. Or we might have to go communicate with our community and get some more feedback before we can actually test our ideas, right? So it's a much more circular process than a linear process. So those are the 8 science practices. And as you can see, they do a lot of overlapping with what you already know about the scientific method. So we'll be working on this for the next few days in class and doing lots of practice. And that's it, folks. Have a good rest of your day.